what are they called, the makerbot? Method X's. The Method X's have interchangeable nozzles. The Method X's will print 2 filaments at a time. The Method X's will print carbon fibre and everything else that you put in them. These print PLA, pretty much. Right, they're set up for PLA. They've got a front door, they've got a touchscreen panel, everything's on magnets, so that closes on magnets. This pulls off on magnets and just locates on magnets. It's quite user friendly. The on-off switch, perversely, is round the back. Turn it on. Takes 1, 2, 3, 4. Okay, somebody switched them off at the back. It shouldn't need to be switched off at the back. This is not 1940s where things ran on. Now, they're on. Did you come to life yet? No. Just temperamental. Plug them on. Now give it 3 seconds, it'll come on. Right, if we look at it, inside, it's got, we'll look at the inside first before I start talking about things. It's got a bed. If you push down on the front of the bed, it's spring loaded and the bed comes out. Right? The bed doesn't like your greasy little fingerprints. So try and keep your fingers off here, because the next person that prints it will delaminate, it will come off. You don't need to, like the old ones, which we don't really use, the legacy ones, you used to have to put print stick, glue stick onto it to make the stuff adhere. This has got a heater bed. It heats it up to just about the right temperature to make the filament stick on it. Right? This is an FDM printer, fused deposition modeling. Right? So it deposits, goes round in a circle, and then deposits on top at just the right temperature for it to fuse to the layer below. And then it goes round and it fuses and it goes round. So it's fused deposition modeling, FDM. Right? There's lots of different sorts, but this is fused deposition modeling. When you end up taking your print off, these are deliberately flexible. Again, there are gloves in that drawer if you've got greasy fingers. Trumpold wears them. There's lots of hands being in them. I'm a bit OCD about putting my hands in gloves that other people have had their hands in. So I don't touch there. You can flex it that way. This is not a strength competition. You're not trying to bend it and break it, because it probably will do. That flex there, followed by that flex there, is enough to pop your model off. Right? Now, in terms of, what was I just talking about in the room? Constraints, 15 centimeters by 15 centimeters, and from the bed height to the extruder is about 15 centimeters. So that gives you your constraint. Your model cannot be bigger than that. When you put it back in, you slide it in there and you push it there. And you will see that it's got a Z-axis up and down. It's got an X-axis back and front, and it's got a Y-axis sideways. Right? So there's your 3 axes. Computer numerically controlled, CNC. It takes your 3-dimensional model, which you create in Fusion, but it won't recognize that. You have to export it from Fusion as an STL file, You take this model as an STL file, you then send that model, you save it to your desktop, and you upload that model to the makerbot online slicing tool. It's got an online service. It's all in the cloud, right? Somewhere there's a big warehouse full of machines churning information out. That slicing technology, you have to tell it it's the makerbot sketch. If you accidentally tell it it's the makerbot method X, you'll take the file, you'll stick it in here, and it will go wrong model, wrong machine, and you've wasted 10 minutes. So when you go on to the slicing technology, make sure you identify it as a method sketch, as a makerbot sketch. The slicing technology then slices this up into thousands of little layers, like a loaf of bread. that way. And each one of those layers contains X, Y, Z coordinates. Go this way, so many bits, deposit, come round, deposit, come round, deposit, come round, deposit, come round, deposit. Move up the Z axis, do the same again, do the same again, bop, 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 bop. That's 3D printing in a nutshell, right? There is an extruder there. That extruder has got a yellow sign on it that says I am hot. It is not hot yet, but it will raise to about 220 degrees centigrade. Enough to give you a serious burn. That's a 180 degrees Celsius burn from pewter yesterday on my finger. Right? Just touched the wrong thing. It bloody hurts. It hurt enough to make me swear yesterday. It hurt enough to make me rush and put it under a cold tap. And that blister will be there for probably 3 or 4 weeks. Right? It's not particularly sore now. It's gone perversely hard and I've lost a bit of feeling in the end of my finger. Don't touch that. Right? So that's the extruder. Coming off the extruder is a white tube. The white tube is called the Bowden, or the Bowden tube. And the Bowden tube comes round and comes to 2 metal wheels there. The 2 metal wheels are knurled. If you've ever flicked a cigarette lighter, the cigarette lighter top is knurled. It's got like a crosshatch pattern on just to give it grip. So as it grabs the filament, it rolls up and it pulls the filament up. Right? You don't ever need to take this off unless it's jammed and you are repairing it. I'm showing it you so you can see there's a spring there that adds tension and that's how it grabs the filament. This is a filament holder. We're going to go back round to, and again, don't expect that I think you have to remember this instantaneously now. If you do, that's great, because these are so easy to use. I want you all to be able to say, can I print this, sir? Yes, you can, go and print it. I don't want to waste my life doing it. Right? Filament, PLA, polylactic acid. We use it because it's about as biodegradable as you can get, therefore it's reasonably environmentally friendly. 3D printing on the whole can be environmentally friendly. We don't have to say we're wasting lots of plastics. There is a spool of filament. Right? Fishing filament is the same sort of stuff. Any plastic that's been stretched out into a uniform size and dimension is known as filament. We keep this tense on here, right? And we keep it so by just threading it through there and pulling it tight. On the control panel, there's a very, very simple menu. The first one says print. We're not ready to print yet. Material settings. Leave the settings alone, right? Unless you talk to me or Trumpold about it. Don't mess with the setting. It's possible to change temperature. It's possible to change speed. All of the settings for the manufacturing of your model you can do in the cloud before you slice it. It doesn't need to be any denser for your model than 5% infill. That's more than enough for what we call an aesthetic prototype. Something that's visually, that looks like you want it to. You're not going to stand on it, you're not going to stand me on it, you're not going to throw it around, and it's probably not going to get used properly. Therefore, it doesn't need to be any more solid than 5% infill. That will speed up your print time dramatically, and it will reduce the amount of material you use dramatically. Kids straight away go in at 15, 20%, oh, I want it to be 100% fill, and then 7 days later it finishes printing. You don't need it. The average print on this will be 3 to 4 hours anyway. You are expected to take the model off. You are expected to take the filament off. This any PLA filament is hydrophilic, right? Hydrophobic, something that doesn't like water and pushes water away, like your waxed, your coat that you wear, your shoes when you spray something on them to make them hydrophobic, to push water away. Hydrophilic will absorb moisture. We live in Singapore, it's humid. As soon as that aircon goes off, the cold air comes out, the warm air gets pulled in, and it's got moisture in it. Right, if this starts absorbing moisture, then it changes its qualities when it comes through that extruder. If I heat water to 100 degrees, what happens to it? Boils. Turns to steam, right? Now, 1 centimetre cube of steam becomes 3,000 centimetres of water, becomes 3,000 centimetres cubed of steam. That's why we had steam engines for so long. You could fill the front of the train up with 1,000, 2,000 litres of water, and that train would run for 200 miles because that equated to 3,000 times as much steam and compressive strength and compressive energy. In this, what you don't want is it coming through a 180-degree extruder and creating steam, because it will make your plastic bubble, right? And it gives you poor build quality and poor layers, poor adhesion. It doesn't stick so well, it blows apart, and you'll see the quality of it. We're kind of limited because once we've opened it, it's automatically starting to degrade. We keep it in bags. All of these bags had a little silica gel pouch in it. Right, most of the things you buy on Amazon come with a little tea bag full of silica gel. It's a crystal that is highly, highly, highly hydrophilic and will suck up moisture. And most products don't want to go rusty, they don't want them to go dry, so they put a little packet in. Don't eat it, don't give it to your pets, just throw it away. It's quite bad for you to take in because it will continue to take up moisture and it will block your colon. Right? What was I going to say? Same as pasta, same as noodles. It's fine until you take it out of the packet and then it starts absorbing moisture. So, I'm going to press material. As soon as I press material, it's going to give me two options, load and unload. I'm going to click load. Once I click load, the extruder begins heating up. It knows how hot it wants to be. And it zeroes, it gives itself like the laser cutter, it finds where its home is. Once it's doing that, I'm going to take this off. There's a pair of scissors in that top drawer. Can you pass me the pair of scissors? Unless you can see them lying somewhere else. Lovely. Come here, sir, you can do the operation for me, right? It's a bit like a Jewish ceremony. Snip that for me. On. Thank you. Right? Now, the filament comes off the reel that way, not that way. That will mess the machine up, right? So make sure it goes on that way. I'll put it on there, sorry. I put it on and then I put the filament up that hole there. I'm going to hold it there. As soon as it grabs it from me, which is when the filament's got to the right hand, it will self-spool. And then we can put this back on, job done. That's done till it finishes. Now, the filament's not coming out there, it's going through the Bowden tube and it's getting to the top of the extruder. The extruder is full of whatever was in there last time. It could be grey, it could be brown, it could be gold, whatever it is. And these are really good. The old ones, these ones, every time you took it out, you had to go and you had to pull it out. And regularly they would get blocked and you had to heat them up and stick little needles up inside them. That's why we don't use these anymore, because they're a pain in the backside. These are 5 years younger and 5 years better. That one of Wen Shi's, that machine over there that you can see, belongs to Mark, grade 11 now. His mum wouldn't let him keep it in the bedroom because it's big. He said, if I buy it, can I keep it in your lab? I said yes. Right? The benefits are it's twice as fast, it's half as expensive, and if I want something made really quickly, Mark will make it for me. And it will print in multiple colours. We get a sort of a trade-off. You get to play with your toy when you want to, you don't get your mum battering you. I use your machine sometimes. Right, now you can see it's extruding. And it's pushed some pink out first, and you wait for it to extrude a little bit. This is hot, but as soon as it hits the air, it's getting cold. So I'm going to pull that little snot down there. I'm going to let it continue extruding a little bit, and then I'm going to read this. It may take a few minutes for the material to extrude. Press next when the new material starts extruding. Excess material can be removed after it is cooled. Next. So I'm going to stop it at that point, and I'm going to pull off a little bit of extruded filament. Right? You can see it pushed out the first colour that was there before. Does that make sense? Yeah. Right? So it's now ready to print. You would now take your card with the makerbot file on it, you would stick it in this slot, you would go back on the menu to print, you would click print, it would recognise the card and it will tell you your name on it. It'll say Eugen. right? Or you can hit flask or whatever. And all you do at that point is go print. And then it'll take about 30 seconds, it'll take about 3 minutes, and then it'll start printing. And on this screen it will say, print job, 4 hours, 15 minutes. Your responsibility is not to do this on a Friday. We don't want it happening on a Friday, right? Because it does occasionally go wrong. Every now and then, if you haven't cleaned it, if it has got greasy fingers on that bed, then it'll start doing it, and 3 hours later, it'll come loose. And then it'll just make this bird's nest of spaghetti. And if you leave it doing that for the weekend, you will come back to a mess of spoiled material. So we tell students we don't want this happening last thing on a Friday night. You can probably come in on a Thursday night and say, I'll print it now. It's a 7-hour print. That's okay. We'll come in the morning. If it hasn't worked, shit happens. Right? But we don't want the whole weekend, because the whole weekend is that whole weekend of that filament soaking up moisture. So you're not only throwing away that, but you're throwing away that. Right? And the Method X's are hermetically sealed. They are a bit cleverer, they keep it hot, they use them to dry old material. So they're more expensive machines. They just keep everything in this nice, warm, moisture-free environment. Right, so I'm going to go back to the menu. I'm not printing anything now because you don't need to see anything print. And I'm going to press material, and I'm going to unload. This is your job when you finish printing. You take your model off, you press unload, you wait for it. When it starts unloading, so I'll finish with that, you'll see it start to move. And at that point, you're not wrenching it out because you'll snap the filament in the Bowden tube. That's a pain in the neck. Right, I've got to take the top off, I've got to get the Bowden tube out, or I hope that I can feed some more and it'll push it out and it'll extrude it. But I don't know how much is in there, so it's a pain in the neck. It's starting to loosen off now. Is it? Maybe I'm lying. As soon as you either hear it or see it start to move, then you just put a bit of manual tension on and you just unspool it. It's not ready yet. There. See it go soft? I saw it move. There. Right, and I'm just gently, not quickly, it's doing it for me. I'm just gently unspooling it. The older the filament gets, the more brittle it gets because it's got moisture in. So there's my filament. I take it to, it'll go to there. I take it to there. Don't bother snipping it at this point because you're going to put a kink in it when you do that. Give it a tug. Right, give it a tug. Put the case back on. Switch the machine off. Thank you very much. These drawers here have got Ultimaker material in. The Ultimaker material is 2 mil, or no, it's not. It's not as thin as this stuff. This PLA is, what's it say? It doesn't give me a diameter on it. It should do. I think it's 1.85 mil or something like that. Right? The filament for that is annoyingly wrong. It's a different side, so it'll clog the filaments. Do you understand? Yeah. Right. So some of your constraints are the colours we got. So I want to run out the old stock before I buy new stock. Kids like shiny new stuff. Can I have some gold? Can I have some white? Can I have some transparent? My suggestion is that you just use what we've got for this project, because this project's about getting you started on 3D printing. Right, when it's your big project, your major project for grade 12, then you can use anything you specify. If you want to buy your own stuff, you can do. There's very, very cheap stuff available. You put that back in that cupboard behind you. When we stand it up vertically. Right, so we stand it up vertically because it's something to do with the way it's spooled that stops it sliding on top of each other. Yeah. Right? You can buy glow in the dark. I don't have it and you're not having it. But if you want it, you can buy it. Right? If it's cheap enough that I like it and think, yes, I can make something with that, I might pay you back. Don't presume that. Don't go buying magnetic stuff or glow-in-the-dark stuff and then saying, I bought this, give me the money back, because the answer might be no. Right? My desire is that we get to this point of me being able to say, right, go and print your stuff. Right? One 20-minute lesson is probably not enough. But all my grade 6s listen to me. There's always an expert in the class who gets it and understands it and knows what they're doing. Right? So all of my grade 6s last year, that's 2 classes out of 3, 3D printed their perfume bottles. Even the ones that couldn't speak English very well. Right? They listened, they watched, they did it. Mark Trumpold, I kind of put him in charge of this. When he first came here, he had more print experience than me. I'd used these legacy ones. He liked the makerbot, so I said to him, right, get me a quote, find the best dealer in Singapore, you deal with it. And he got me a quote for what was $50,000 worth of 3D printers, plus materials, plus support. So he very much feels like this is his room. We don't own rooms, but he very much feels like this is his baby. Right? And he will shout at you, and he will get very upset if you come in here and mess around. I will reinstate that camera there is plugged into my phone. Right? This little one here. There are cameras, obviously, if somebody steals something, then security, I can ring security up. That's a pain in the neck. If I'm teaching you and I've sent you off to be in this room, that camera will be on. And if you're rolling around on these chairs, messing around with these, anticipate the wrath of me followed by the wrath of him. All right? These are expensive toys. We're really lucky. When we show parents around, they're like, wow, this is better than some universities have got. Not all, but better than some universities have got in terms of the kit that we've been allowed to have. There is a resin printer over there that will print solid resin models. Right? That's lovely. That's laser. So you get a bath of resin. There's the bath of resin. And the laser does the top of the, imagine it's a knight in a chess piece. It does the top, it laser hits. Does it do that or does it do the bottom? The model comes out of the liquid anyway. It's fantastic. Fantastic system. Oh, the laser comes up from underneath and it hits that resin layer and then the whole model comes out of the resin. Same sort of thing that's used by aerospace. We haven't got a laser sintering. Laser sintering is another one. That's even better. That's a vat, a tray of aluminium powder. And if you hit it with a laser, it doesn't melt, it sinters. It gets to the point where it's not quite liquid and flowing, but it fuses together. And they make genuine aircraft parts using laser sintering because it's hard enough and it's solid metal. Right? So sintering is taking something to the point where it's vibrating enough to fuse, but not dribble away and melt, because you don't want the whole bath turning into a bath of metal. Right? There's lots of different things, but fuse deposition modelling is what you're going to learn on for the time being. Thank you, you are the best so far. That's amazing, well done. You've actually sat and listened. The last 2 classes I was like, well, you behave yourselves. Yes?
How do we send the print to the printers?
You bring it on a USB stick. Now, they are capable of wireless. Right? We're not putting that in that domain. Right? Because then kids will be emailing and printing prints and we lose control. We don't know who made the mess, we're just not doing that. We're sticking to the USBs. In here, we've got a bank of, right, and we'll wipe them or we'll reuse them, but these are just little USB cards, right? We'll have maybe 2 for the class. You'll use them, you'll come down. It's possible, if you know that you and your friend have got small models, you can nest them. So on the slicing software, you can import model 1, import model 2, import model 3 and model 4 even, if they're all going to fit on the same bed. And then you can print 4 models at the same time. Right? But then that's for you to look at when you do it on the, we'll look at this later on. What I've said to the rest of my classes is that the next lesson we will go through the whole of the first tutorial together, because I asked 2 classes yesterday, not one of them had looked at the tutorials on Fusion. That's a position I don't want to be in 2 weeks' time, because there's no way you can finish this if you haven't done it. So we will go through next lesson the whole of the first tutorial. If you've already done it, then you're going to be my assistant and you're going to run around helping people, because like me, they'll be going, what? Right? That's going to be next lesson. This lesson, I'd like you to go back. I'd like you to first of all transfer your old slide into Teams, and then I'd like you to move on with whatever you are doing. We should aim to get the design brief finished by Wednesday, Thursday, Friday.
What is the design brief for?
A4 is the design brief. A4 is you proving that you've done the research. You imagine me to be your boss. You imagine me to have a factory. You're all my designers. Only one of you is going to get the Christmas toy made. So I'm going to look at all your design briefs. Based upon the strength of your research, if you can convince me that yours is the best toy, right? Based on my research, 60% of the adult population of Finland are alcoholics. Further research suggests that they like shot glasses and they like drinking vodka. As a deterrent act, right, there are 3,000 deaths per month in Finland from alcohol. This is all convincing me there's a problem. Then you're going to say, I have designed and made a shot glass that is impractical and would be a good toy for, people to give their fathers to stop them drinking. Based on my research, 6 out of 10 of my classmates said they would buy this for their dads. Based on my research of Fusion 360 or of the printing machine, I could print 4 in one go. Based on my research of average size shot glasses, they will be 8 centimeters high by 6 centimeters wide by whatever, right? Based on my research of filaments, or my research of filaments tells me that I need to use the polylactic acid will be dissolved by vodka, so that's a really bad idea, right? I will use this one instead. I will design and make an impractical shot glass by the middle of October, giving me enough time to evaluate it and hand the project in. Full stop. That's a design brief. When I read a good design brief, I will know a good design brief because it will talk about the client. You should have your primary client and potentially the second. My primary client was my brother there. The secondary client is the whole population of alcoholics. I will get into big trouble if anybody here is doing alcohol, just because Miss Tammy lived in the Middle East for a long, long time. Right, so she was in Dubai. Alcohol is pretty much forbidden, unless you are every single white person that lives there that goes home and drinks lots of it, but pretends they don't. Right? So I don't want to upset people, so try and stick to something that's, unless you've got a really good reason like I have, my brother. All right? Smoking, less so. Everybody wants people to stop smoking. That's a reasonably good thing. You're not promoting smoking, you're promoting stopping smoking. You're not promoting drinking, you're promoting stopping drinking. Well, I can get away with that probably, but not if you're all doing it. Fair? Right, let's go back to class. Thank you very much. That was a very